Alright, let's talk about Dalton's Law of partial pressure. So basically, in a mixture of non-reacting gases, that's really important actually, non-reacting gas mixture, we can confidently say that the total pressure is equal to its parts. Alright, the total pressure is equal to its parts. So basically what that means is when we have a total pressure, the sum of the pressure, and now this is usually in a confined space, like the volume is held constant because the volume is not really going to change that much. That's more of a Boyle's law, so you can reference my Boyle's law video on that. But the total pressure is equal to the sum of its parts. And that kind of makes sense, right? If we add up every gas is pressure, that's going to give us the total pressure. Okay, so let's talk about what pressure and partial means. So partial by definition is existing only in part, not complete. Right, so it means parts. So there's three parts in this equation. Each one is a pressure. And what pressure is a continuous physical force exerted on an object. Right, so it's coming in contact with something, and we measure that force in atmospheres or kilopascals. There's a lot of different ways we can measure pressure. It's not really universally agreed on what we measure pressure with. Okay, but we can confidently say that this law is talking about the parts of pressures in a total pressure, right? So part pressure is these three variables here. So I always kind of think about a football when I think about things that are confined in a space. Right, because a football, you know, it's pumped up with a little pump, right? You can use those little handheld pumps. Look like this, kind of. Those are useful to pump air in there. And what we use for air is usually nitrogen, oxygen, and carbon dioxide. And when I say when we use it for air, that's what's in the air. It's mostly nitrogen, mostly oxygen, and then as well as carbon dioxide. And then there's some argon and some other gases as well, but those aren't nearly as potent and large in quantity in the natural air. But a pressure then, the partial pressure in a football would vary from the amounts of gas and amounts of pressure in it, because it's going to be a mixture inside of the football. So let's try a practice question. A football contains three gases, oxygen, carbon dioxide, and nitrogen. If the partial pressures of three gases in the football are 35 atmospheres oxygen, 5 atmospheres nitrogen, and 25 atmospheres, that's supposed to be CO2, what pressure would Tom Brady and the Patriots deflate the ball to? No, I'm just kidding. That's just a joke on Deflategate. But what is the total pressure inside of the tank? So we just gotta kind of write this down, and basically you can assign each gas to a letter. So we have 35 plus 5 plus 25. 25 plus 5 is 30, plus 35 is going to give us our total pressure, 65 atmospheres. All right, and even inversely, if we weren't given one of these, let's say that PB was the one we were without, you could still figure this out, right? Because of this is addition, we could subtract this, saying, okay, 65 minus 35, 25, well, that's 5. That means PB has to be 5. Right, so you can kind of use your intuition and figure out which one when you're given a variable that's missing. All right, and that's going to come when you need to read a question critically. Thanks for watching. If you have any questions, comment below.